Welcome to MIT 1033 Test 2 Review Study Session. Let's start with question number 1. Give me just a second to move to the next page right here. So the first question says, decide whether the ordered pair is a solution of the given system. So we're dealing with systems of linear equations, and we are given two equations. Most likely they are crossing at one point, and we're basically checking if the point, which is right here, -3, is a solution to the system. What I would do is I would use this point and plug it into either one of the equations, check if I get a true statement, and if I do, plug it into the other equation to verify that it is also true, which means that then the point would be a solution to the given system. If by any chance we should get a statement that is not true, then obviously this point is not a solution of this given system. So I'm going to start with the first equation because it also looks easier to solve. So let's do 4x plus y equals -9. And we're taking our point. This is our x value, this is our y value, and we are plugging it into this equation. 4 times -3 plus -3 equals -9. Okay, 4 times -3 is -12. And a positive times a negative is a -3, and all that is equal to -9. Now, -12 minus 3 is -15, which is not equal to -9. So right here we can actually stop because this means that the point is not even part of this first equation, so automatically it is not a solution to this given system. So the answer should be no. And in your review packet, this is choice B. Okay, now let's move on to question number 2. This one says, solve the system of equations using substitution. So there are basically 3 different methods of solving systems of equation. We have substitution, graphing, and the elimination method. Let's start doing the substitution method. When we're using substitution, that means we need one variable all by itself. And in this case, right here, it is already set up, y is all by itself. So we're going to use this equation to substitute it into the first equation for the variable y. So using this first equation, we are going to plug in our 4x for y. And then we are going to solve for x. So you can add an imaginary 1 in front if that's easier for you to solve the equation. So now we have 1x plus 4x is 5x, which is equal to -5. Then we have to divide on both sides by 5. Now x is by itself, and -5 over 5 is -1. So we found our x value of the point that those two lines are crossing. Now we have to find our y, which means we have to plug in our x value in either one of these two equations. And we can choose. Usually I pick the one that looks to me easier to solve. In this case, I'm going to choose the second equation. So y equals 4x, and I'm going to plug in my -1 for x. Solving this, I am getting y equals -4. I found the solution of the system which crosses at the point -1, -4. And in your packet, this is answer choice C. Let's move on to question number 3. This is also a system of equations, but this time they want us to use the elimination method. The elimination method can also be referred to the addition method. Sometimes you hear the word addition method because what you're actually doing is you're adding these two equations together. But the main goal is that at least one of the variables must cancel out, and that happens if they are opposites. If I'm looking right here at the positive y and the negative y, this is the condition that when I'm adding the two equations down, that the y would be eliminated. It will add down to be 0. So let me rewrite my system. So in this case, this was already set up for us sometimes, and maybe we see that later in the online study session, we have to manipulate the equations so they would fit to be the opposite to cancel out. So we're adding these two equations together. We can add an imaginary one in front if that helps. So 1x plus 1x is 2x, and then I have 1y, and I subtract the y. Now this cancels out. It's 0. I don't really need my 0 because I already have something on this side. And then 12 plus 4 is 16. Now I divide by 2 on both sides to isolate the x, and I am left with x equals 8. Okay, I found my x value. Again, I'm choosing either one of these to plug in my x value to get my corresponding y value to this point. And I am choosing the second equation because, again, for me it looks like it's easier to solve. The numbers are smaller. And I'm going to plug in 8 for x. And now I'm solving for y, so subtract 8 from both sides, which gives me a negative 4. Divide by a negative 1 on both sides. Now y is by itself, and negative 4 over negative 1 is a positive 4. I found my point, 8, 4. This means that these two equations are crossing at the point 8, 4 in the coordinate system. And in your packet, this is answer choice B. Question number 4 says solve, but these two equations also represents a system of linear equations, and because it says solve, we can choose which method to use. So let's look at this. Because this is not set up that the x is underneath each other, the y is underneath each other, and then the constants, the elimination method would be harder to go with this problem, but the substitution method would be an easy choice because the second equation is already solved for y. So we can use this to plug it into the first equation for the variable y. So x plus y equals 0, and we are going to plug in negative 4x minus 3 for y. Now let's solve. Let's get rid of the parentheses. We're distributing the sign. Nothing should change. So negative 4x minus 3, and that equals 0. Now I am going to combine these two x values. So I have 1x minus 4x gives me negative 3x minus 3. Then solving for x, we add 3 to both sides. Negative 3x equals 3, and we're dividing by negative 3 on both sides, which leaves us with x equals negative 1. Okay, we found our x value. Plugging it back in to get our y value. It is your choice which one to pick. Both of them should give you the same answer. I am going to choose the first equation to plug in my x value. So I get negative 1 plus y equals 0, and I'm going to solve for y, so I'm adding 1 to both sides. And my y value is positive 1. So the point that the two lines are crossing is negative 1, 1. And in your review packet for question number 4, that should be answer choice D. All right, so let's see question number 5. A lot of systems of equations on this test, and this even has fractions involved, but don't get discouraged. There is a way of eliminating the fractions right off from the beginning by finding the least common denominator and then multiplying by the least common denominator. So let's do this first before we start with the substitution, and let's just eliminate the fractions. If I look at this first equation and the denominators are 5 and 8, my least common denominator would be 40. So I'm going to multiply each term of this equation by 40, and that should cancel out my denominators. So the first one, I'm going to multiply this by 40, and also the last term by 40. I can put it over 1 if that helps me. So now before I multiply these together, I can cross cancel those two fractions. I need to find a common factor of 40 and 5. Both of them have a 5, so 5 goes into 5 one time, 5 goes into 40 8 times. Here again, the same thing, I can put it over 1 if that helps me, and then I can cross cancel the fraction because 40 and 8 share a common factor of 8, so 8 goes into 8 one time and 8 goes into 40 5 times. And here I can cancel nothing, they don't have any denominators to cancel. So now I can multiply together my leftover numbers. 8 times x is 8x, 5 times y, or negative 5 times y, negative 5y, and all that is equal to 1 times 40, so 40. I finished with my first equation. I got rid of the fraction. This is still the same equation, and I'm going to do the same thing with the second equation, and in this equation my least common denominator, because it's only 1, it's 9. So I'm going to multiply every term of this equation by the least common denominator, which is 9. And times 9. So again, these cross cancel. They share a common factor of 9, so 9 goes into 9 one time, 9 goes into 9 one time. Nothing cancels here, nothing cancels here. So I'm rewriting my equation with what's left over. So I got an x, negative 9y, and 8 times 9 is 72. So I got my both equations set up. Now I can start using substitution method, which says I need a variable by itself, and I'm going for this one because this one doesn't have a coefficient, a number other than 1 in front. So I'm solving for x, add 9y to both sides, and I got x equals 9y plus 72. Now I can use this equation and plug it into my other equation for the value x. 8, and then I have 9y substituting for the letter x plus 72, and continuing with my equation minus 5y equals 40. Now I'm using distributive property to eliminate the parentheses, and I have 8 times 9y gives me 72y, and then 8 times 72, that should be 576, bringing down the rest of my terms. Now, because I'm solving for y and I have 2 of the y terms, I'm going to combine them. 72 minus 5y gives me 67y plus 576, and that is equal to 40. Bringing the 576 over to the other side by subtracting, I'm left with 67y equals, and then I have 40 minus 576, that should give me a negative 536. Okay, one more step. I have to divide by 67 on both sides. To be really careful to write it here, I'm running out of space. And that leaves me with y equals, goes in evenly, negative 8. So I found my y value. Now I need to find my x value. So I'm choosing either one of the equations that I have got rid of the fractions, so which means either this one or this equation, and I'm going to choose the second equation I solved because that looks easier for me to plug in my y value. Times negative 8 plus 72. So x equals 9 times negative 8 is negative 72 plus 72, and that leaves me with x equals 0. So I found my point, 0, negative 8. This is where those two lines crossing on the coordinate system at 0, negative 8. And in your review packet, this is question 5, and that should be answer choice B. Okay, now I put in an extra slide because I believe you guys might need this information to be able to solve the next couple of questions on your test, and I don't know if this was sufficiently covered in the academic systems modules. So when you're dealing with systems of linear equations, you could have 3 different types of solutions when you're solving these. You could have one solution, and that represents 2 intersecting lines. They intersect at one point, and that's why you get this one solution. You could also have infinitely many solutions, and that happens when you are solving a system where the 2 lines are actually the same. They are on top of each other, which means every single solution from one equation would also be a solution to the other equation. And the third option you have when you're solving systems of linear equations, there could be no solution, and that happens when the 2 lines are parallel. They never cross, which means there's no intersection point, so no solution. The first 2 options with the one solution and infinitely many solutions, both of these systems are consistent. So whenever you actually get a solution, you have a consistent system, and these could be broken down into an independent system, which means these 2 lines that are intersecting, they are independent of each other. The only thing they have in common is this one intersection point, but all the other points are independent. And then the other one with the infinitely many solution would be the dependent system, because every single point from one line depends on the point from the other line. And then systems where you have no solution would be considered inconsistent systems. So when you are solving these, usually when you have a system with one solution, answers that you get is you will get your x value, which equals something, and then you will get your y value, which equals something. When you're solving systems with infinitely many solutions, you should get at the end a true statement answer, which means, for example, 0 equals 0 or 3 equals 3. Anything that makes sense and is a true statement that would represent infinitely many solutions. And if you're solving a system with no solution, then your answer usually looks like, for example, 0 is not equal to 3, or 5 is not equal to 1. So you would get two answers, or one answer basically, where both sides are not equal to each other. So I hope this makes sense, and we should be able to solve the next couple of questions. So number 6 says solve the system. It doesn't state which method to use, so we can choose any. And because the variables are nicely lined up, I'm going to choose the elimination method. But before I can use the elimination method, I'm going to have to make sure that these variables are opposites. So the only thing I have to do is, for example, if I'm choosing x to be the opposite, I have to multiply one of these equations by a negative sign. So I'm going to multiply the top equation by a negative sign, and that should change all the signs of this equation. I should get a positive 1, not a negative 1, because a negative times a negative is a positive. So that is equal to 1. And then I'm writing my second equation underneath. And when I'm adding those two equations down now, negative x plus x gives me 0. Negative y plus y gives me 0. And 1 minus 2 gives me a negative 1. So 0 plus 0 is 0, equal to negative 1, which is not true. So you might see right away this is a system with no solution. And systems with no solution, if you go back to the previous slide, are inconsistent. So the only choice that we have here is answer choice B. No solution, and this is an inconsistent system. In your packet, that is, or you obviously see it right here, answer choice B. Okay, question number 7 also asks us to solve the system, but doesn't state how they want us to solve it. So we can choose, but again, because this is nicely set up with the variables and then the constants, I'm going to use the elimination method. So I need opposites. I'm going to pick x to become the opposites. So to be opposites, I have to multiply the first equation by a negative 2. So multiplying through by a negative 2 gives me a negative 2x, and a negative 2 times a 6y is a negative 12y, and a negative 2 times 29 gives me negative 58. So writing my second equation underneath, some of you might already see what's going to happen, but I'm going to work out this problem finish. And when adding these two down, the negative 2x plus 2x is going to be 0. The negative 12y plus 12y is going to be 0. And negative 58 plus 58 is going to be 0. But different than the previous problem, this time I have a true statement. So if I get a true statement, that only can be a system where the two lines are exactly the same. they are on top of each other, which means they have a solution, they are consistent, and because they're on top of each other, every point depends on the other, so consistent, dependent. And the only option I see being consistent and dependent is answer choice C. Okay, now let's go to the next problem. In this case, they're actually telling us that they want us to use substitution, and we have two choices because both of these variables are already solved for. I am going to take this one and plugging it into the second one for y. So using the second equation and plugging in the first equation, just a second, I slipped. Okay, right here. So using the second equation and plugging in the first equation. So my y now becomes x minus 9 plus 6, and that is equal to x. So the parentheses doesn't really mean anything. I could just drop them. Nothing changes. And then I'm going to solve for x. So combining these two numbers gives me -3. Bringing the x over to the other side. I'm left with -3 is equal to 0. This is not true. Again, this system has no solution. Systems with no solution are inconsistent, and my answer choice here would be A. No solution, inconsistent. So I just wanted to mention that I had to re-record the first 8 questions because in the other actual online study session, it happened that the first 8 questions didn't record. So I'm going to stop right here, and I also upload the other video, and there you will be able to see questions 9 to 25.